In today's lesson, we are going to learn how to multiply and divide numbers in scientific notation. Here are the 3 steps for when we are multiplying two numbers together that are in scientific notation. We will multiply the coefficients and then add our exponents and then always check for proper scientific notation. And here, down below, I have just a quick review. Here's a property of exponents that we have already learned, and we're actually basically applying this property to scientific notation. Here we multiply the coefficients 2 times 3, which is 6, and then our exponents we end up adding, so it's x to the power of 10. So we're going to apply that same concept to scientific notation. So here we are multiplying two numbers in scientific notation, but really if you break this apart, we're multiplying here, we're multiplying here, and we're multiplying here. We're just multiplying all of these together, and you can multiply in any order. So what I'm going to do is get rid of my parentheses, and I'm going to write my two coefficients first, because I can do 7.2 times 1.6 and then match up my powers next to each other. So times 10 to the third times 10 to the fourth. So really what we're doing is we can first multiply our coefficients together. 7.2 times 1.6 is 11.52. And then times, here we're multiplying two powers with the same base, and that property says you add your exponents, so it becomes 10 to the power of 7. So we multiplied our coefficients, we added our exponents, now we have to check for proper scientific notation. 11.52 has to change to 1.152, and then times 10. Let's see, if my coefficient decreased by a decimal, my exponent has to increase by 1. So there we go, 1.152 times 10 to the power of 8. So here's our second example. First, because we can multiply in any order, we're going to multiply our coefficients together. 8.4 times 2.5. And then I'm going to multiply my powers together. 10 squared times 10 to the power of 6. Well, 8.4 times 2.5 is 21. And then here, multiplying powers with the same base, add my exponent, so it's times 10 to the power of 8. Now I just have to change to proper scientific notation, so 21 changes to 2.1. And if it decreases by 1 decimal place, my exponent must increase. So times 10 to the power of 9. I would say that is pretty easy peasy lemon squeezy. In this example, we have a negative exponent in one of our numbers, but we still follow the same steps. Multiply your coefficients. 2.63 times 1.2. And you should get 3.156. And then it's always times 10. And then to the power of, add your exponents. 4 plus negative 3 is 1. So we multiplied, we added, and then we have to check for proper scientific notation. And it is already in proper scientific notation. So we had to do one last step. Okay, last example where we are multiplying, and then we can do some division. But first here we multiply our coefficients. What is 9.75 times 8.4? it is 81.9. And then times 10, we have to add the exponents. What is 3 plus negative 6? That is negative 3. And now we have to change to proper scientific notation. So we need to here move the decimal. So it's 8.19. And if we decreased by moving the decimal one place, our exponent has to increase by 1. So times 10, and if our number increases, it really means a smaller negative, so it's to the power of negative 2. Now we can start dividing numbers in scientific notation. And it's very similar, except instead of multiplying, we obviously divide our coefficients. And then instead of adding exponents, we subtract exponents. And then once again, you're always checking for proper scientific notation. So here I just have a quick review because we're applying this property to scientific notation. Here, your coefficients, you just treat that like a fraction or a division. 10 divided by 2 is 5. But then here, if you have 7x's on top and 5 on the bottom, you'd subtract, so it'd be x to the power of 2. Okay, so let's use those steps to solve this problem. We first have to divide our coefficients. So what is 7 divided by 3? When you divide, you should get 2.3 repeating. So let's just round that to 2.3. And then times 10, when you're dividing powers with the same base, you subtract your exponents. 9 minus 8, which is 1, so 10 to the power of 1. And now let's check for proper scientific notation. And because the decimal is right after the 2, we're good. It's already in proper scientific notation, so that was super easy. Okay, let's do another one. First, we have our coefficients, 9.45 over 1.5, and we can just divide them, and we should get 6.3, and then times 10 to the power of, subtract your exponents. 10 minus 6 is 4. And this one is also already in proper scientific notation. Nice and easy. Okay, example number 3. This one is just a little bit more difficult, but not bad. Here, if we divide our coefficients, 1.14 divided by 4.8, we get 0.2375. And then if you look at your powers, we have to subtract exponents. Common mistake, students say, hey, that equals 0. But it doesn't, because 6 minus negative 6 really means add the opposite, so it is actually 12. So now we have times 10 to the power of 12. But we have to check for proper scientific notation, which we do not have. We have to change our coefficient to 2.375. And if we increase our coefficient by moving the decimal one place, so we're increasing here, that means we have to make up for it by decreasing our exponent, so times 10 to the power of 11. Okay, real quick, let's do our last example. So dividing these two numbers in scientific notation, let's divide our coefficients. 9 divided by 2.4 is 3.75, and then times 10 to the power of, what is negative 11 minus 8? If we're subtracting from a negative, it will be a bigger negative. So this ends up being negative 19. And it's already in proper scientific notation. So we're done. So, how does it feel to now be an expert on multiplying and dividing scientific notation? Have fun with the lesson.